Well, here we have a proportion problem, and let's read it. An article reports the price of gasoline has grown 12% to $2.40. What was the price before the increase? Well, to start off with, we must realize that 100% in decimal form equates to 1. And 112%, if it's grown by 12%, we'll add 12% to 100. We get 112%, which equates in decimal form to 1.12. Now the proportion will be price over percent, or in decimal form, P over 1. So the original price was P, we don't know what it was, and P was 100% of the price at that time. The new price is $2.40, and that's been increased by 12%, so its decimal representation then will be 1.12 of the original price. So we have value over percent, value over percent. Now solving for P, look, P over 1 is simply P, isn't it? And if we carry out this division, and in this case we want to use a calculator, we'll get $2.14. And that was the starting price of gasoline prior to the price increase. Okay, for this problem we're dealing with the unit rate, and unit implies 1 in mathematics. For example, if you have a unit circle, that's a circle of radius 1. If you have a unit square, that's a square such that the length of each side of that square is 1. If you think about gasoline and you say, well, I get 20 miles to the gallon, that's a unit rate because the denominator is 1 gallon, and so on. So let's buy these apples, and for these apples you pay $14 for 8 pounds. LBS, excuse me. LBS. And when you carry out this division, the long division, or use a calculator, what you're going to get is $1.75, and that's going to be per pound. And we don't have to write a 1 as a coefficient on the pound symbol. The 1 is understood. So $1.75 per pound, and that's our unit rate for the apples. Okay, so we're going to convert 1,000 inches to miles, and we're going to use dimensional analysis, and we're going to use unit multipliers, which are just forms of 1 that enable us to get rid of the units we do not want and attain the units we need. So we'll start off with 1,000, we'll always start off this way, inches over 1. And now we have to get rid of the inches, and we'll go convert from inches to feet. So there's 12 inches, and we'll put the inches in the opposite position, that way the units inches divide out, and there's 12 inches per 1 foot. Now we'll convert from feet to miles. And so we know, let's see, feet are upstairs, so we need them downstairs, so that way the units divide out. 5,280 feet. And miles go upstairs, 1 mile. And let's see, the feet divide out, the inches, because they're in opposite positions, divide out. And we just have this division to carry out. And you use your calculator, and when you do carry out that division, you get 0.015, and we'll round up to 8 here. And the units, the only units left standing are miles. So less than 2/10 of a mile. Okay, so we're going to do another dimensional analysis problem again. And so a car is driving at 50 kilometers per hour. How far does it travel in 3 seconds? Whew. Well, let's see. We'll start off with 3 seconds. Stick that over 1. And it's traveling at 50 kilometers per hour. Well, we've got to get rid of these units of time. So let's get rid of the hours first. So how many minutes in an hour? Well, we need to put hours upstairs. It has to be in opposite position, so the hours divide out in there. 60 minutes in an hour. Now we have to get rid of the minutes, and we'll get rid of the seconds also. We know minutes have to go upstairs, and there's 60, excuse me, there is not 60 minutes, 1 minute in 60 seconds. And that's going to equal, let's see if we have it. The minutes are going to divide out, the seconds will divide out, and the hours will divide out, and the only units we have left are kilometers. And if you carry out this division of 3 times 50 divided by 60 divided by another 60, what you're going to get in rounded form is 0.042 kilometers. And that's how far you travel in 3 seconds.